Hey, AWS enthusiasts! Welcome back to the Tech Think Tank. I'm Jason, and today we're diving deep into episode 4 of our series on mastering AWS interviews. If you're serious about acing that next big interview or just expanding your AWS knowledge, you're in the right place. In our previous episodes, we've covered a ton of ground, from foundational questions to more advanced scenarios. If you haven't checked those out yet, be sure to hit the playlist linked above or in the description after watching this video. But guess what? Episode 4 is where things get really interesting. We're tackling some of the most intricate and challenging questions that might just be the game changer in your next AWS interview. So, grab your notepads, hit that like button, and let's elevate your AWS interview game to the next level. Now, AWS interviews aren't just about memorizing facts, they're about demonstrating your problem-solving skills, understanding how AWS services work together, and showcasing your expertise in real-world situations. In this episode, we're going to do just that. Before we jump in, if you're finding value in these videos, don't forget to subscribe and ring that bell to stay updated with the latest AWS insights. I love hearing your thoughts and experiences, so drop a comment below with your favorite AWS interview question or any topics you'd like us to cover in future episodes. Alright, no more waiting. It's time for episode 4 of Mastering AWS Interviews, the ultimate guide to the top 250 plus questions. Ready to level up? Let's get started. When do I prefer provisioned IOPS over the standard RDS storage in AWS? Choosing between provisioned IOPS and standard RDS storage in AWS depends on the specific performance requirements and characteristics of your database workloads. Provisioned IOPS is typically preferred when you need a higher degree of control and predictability in terms of input-output operations per second. If your application demands consistent and reliable performance, particularly for critical and high-performance workloads like online transaction processing, OLTP, systems or IO-intensive applications, provisioned IOPS is the recommended option. It allows you to provision a specific number of IOPS based on your application's needs, ensuring stable performance even during periods of increased activity. In contrast, standard storage provides a baseline level of IOPS without specific guarantees. So, if your application has less stringent performance requirements and you are looking for a more cost-effective solution, standard storage might be suitable. Ultimately, the choice between provisioned IOPS and standard storage depends on a careful assessment of your application's performance needs, budget considerations, and the criticality of consistent I/O performance to your overall system. If I am running on my DB instance a multi-AZ deployment, can I use the standby DB instance for reading or writing an operation along with the primary DB instance? In Amazon Relational Database Service, when you set up a multi-availability zone deployment, AWS automatically provisions and maintains a standby replica of your primary DB instance in a different availability zone. The primary purpose of this standby replica is to enhance availability and provide failover support in case of a failure in the primary availability zone. By default, the standby replica is not available for read or write operations. It is in a standby mode, serving as a passive failover mechanism. However, you can leverage the read replica feature in Amazon RDS to offload read operations from the primary DB instance to a read-only replica. If you want to perform read operations on the standby DB instance in a multi-AZ deployment, you should consider creating a read replica from your primary DB instance. The read replica can be in the same or a different availability zone. This read replica can then be used for read-heavy workloads, allowing you to distribute the read traffic and potentially improve overall performance. Which AWS services will you use to collect and process e-commerce data for the nearby real-time analysis? To build a comprehensive architecture for collecting and processing e-commerce data for nearby real-time analysis on AWS, a combination of services can be strategically employed. Amazon Kinesis Data Streams is an ideal starting point for ingesting real-time data from various e-commerce sources, as it provides a scalable and durable platform for streaming data. The collected data can then be directed to Amazon Kinesis Data Firehose, which acts as a buffer and facilitates delivery to different destinations like Amazon S3, Amazon Redshift, or Amazon Elasticsearch. Amazon S3 serves as the primary storage solution for raw, unprocessed data. With its scalability and durability, S3 functions as a reliable data lake, allowing for organization and accessibility for further processing. AWS Glue can be employed for ETL, extract, transform, load, jobs, enabling the transformation of raw data into a structured format suitable for analysis. AWS Glue also offers automated metadata discovery, streamlining data cataloging. For data warehousing and analytics, Amazon Redshift is a powerful choice. Its fully managed, petabyte-scale capabilities support complex queries on large datasets with high performance. In parallel, Amazon Elasticsearch can be utilized for full-text search capabilities, offering near real-time search and analysis functionalities. To visualize and derive insights from the processed data, Amazon QuickSight can be employed for creating interactive dashboards and reports. AWS Lambda functions can play a crucial role in event-driven, serverless processing triggered by events from Kinesis data streams or S3. Lambda functions offer the flexibility to perform additional processing or enrichment in response to specific events. Monitoring and logging are essential components of any data processing pipeline. Amazon CloudWatch can be set up for these purposes, providing insights into the health and performance of the architecture and triggering alerts for any potential issues. By orchestrating these AWS services, you can construct a robust and scalable infrastructure tailored to the unique requirements of collecting, processing, and analyzing e-commerce data in near real time. The specific configurations can be adjusted based on the intricacies and scale of your e-commerce platform. A company is deploying a new two-tier web application in AWS. The company has limited staff and requires high availability, and the application requires complex queries and table joins. Which configuration provides the solution for the company's requirements? For a new two-tier web application in AWS with high availability needs, limited staff, and complex query requirements, a suitable configuration would involve Amazon RDS with a multi-AZ deployment for the relational database tier. This ensures automatic failover to a standby instance in a different availability zone, minimizing downtime. The web tier can leverage Amazon EC2 instances deployed across multiple availability zones for fault tolerance, and auto-scaling can be used to manage instance capacity dynamically. To address the requirement for complex queries and table joins, consider implementing Amazon Elasticache, specifically using the Redis engine as an in-memory cache. Elasticache can significantly enhance query performance by reducing the load on the database and accelerating frequently accessed data. This configuration not only provides high availability for the application but also optimizes query processing, all while requiring minimal operational overhead for the limited staff. In summary, a combination of Amazon RDS multi-AZ deployment, EC2 instances with auto-scaling, and Amazon Elasticache for query acceleration offers a robust and scalable solution tailored to the company's requirements for high availability and complex query processing in a resource-efficient manner. Which statements used in cases are suitable for Amazon DynamoDB? Amazon DynamoDB is ideal for scenarios requiring seamless scalability, low latency performance, and minimal management overhead. It excels in applications with unpredictable workloads, providing automatic scaling to handle varying demands efficiently. With consistent single-digit millisecond response times, DynamoDB is well suited for real-time analytics, gaming leaderboards, and applications demanding low-latency access to data. DynamoDB's NoSQL data model, supporting key-value and document structures, makes it a strong choice for applications with evolving data requirements. Its serverless architecture integration with AWS Lambda, managed services for infrastructure tasks, global distribution capabilities, and built-in security features contribute to its suitability for a range of use cases. Whether managing variable workloads, prioritizing low latency access, or requiring a fully managed solution, DynamoDB offers a flexible and powerful database service for diverse application needs. Your application has to retrieve data from your user's mobile every 5 minutes and store the data in DynamoDB. Later every day at a particular time, the data is extracted into S3 on a per user basis, and later your application is used to visualize the data to the user. You are asked to optimize the architecture of the backend system to lower cost. What would you recommend doing? To optimize the backend system and lower costs, transition from a polling-based approach to an event-driven model for data retrieval from user mobile devices. Implement AWS AppSync or Amazon API Gateway with AWS Lambda to trigger updates in DynamoDB only when new data is available, eliminating the need for continuous polling and reducing unnecessary data transfer costs. Schedule a daily AWS Lambda function to perform data extraction from DynamoDB to S3 on a per-user basis at a specific time. This approach ensures efficient resource utilization, with DynamoDB's on-demand capacity mode automatically scaling based on the workload, contributing to cost savings. For data visualization, opt for a serverless solution like AWS QuickSight, which dynamically scales based on usage, eliminating the need for additional infrastructure provisioning and maintenance. By adopting these optimizations, you streamline data retrieval, reduce unnecessary operations, and leverage serverless solutions, ultimately optimizing the backend system's cost-effectiveness while meeting the application's requirements. You are running to website on EC2 instances that can deploy it across multiple availability zones with a multi-AZ RDS MySQL extra large DB instance, etc. The site performs a high number of small reads and writes per second and relies on the eventual consistency model. After the comprehensive tests, you discover that there is read contention on RDS MySQL. What is the best approach to meet these requirements? To mitigate read contention on your RDS MySQL instance caused by a high volume of small reads and writes, consider implementing read replicas. Distributing read traffic across these replicas helps alleviate the load on the primary database instance, enhancing read scalability. Additionally, leverage Amazon Elasticache to introduce caching for frequently accessed data. Elasticache, using the Redis or Memcached engine, reduces read requests to the database by serving data directly from the cache, particularly beneficial when eventual consistency is acceptable. Optimizing the database structure, including indexes and queries, is crucial for efficiency. Review your schema, create appropriate indexes, and optimize queries to minimize contention. If contention persists, evaluate sharding as a solution to distribute the load across multiple RDS instances. Finally, assess whether adjusting provisioned IOPS or vertically scaling EC2 instances could address performance bottlenecks. A combination of these strategies tailored to your application's needs can significantly enhance the overall performance of your website. A startup is running a pilot deployment of around 100 sensors to measure street noise and air quality in urban areas for 3 months. It was noted that every month around 4 gigabytes of sensor data is generated. The company uses a load-balanced auto-scaled layer of EC2 instances and an RDS database with 500 gigabytes standard storage. The pilot was a success, and now they want to deploy at least 100K sensors, which need to be supported by the backend. You need to store the data for at least 2 years to analyze it. Which setup would you go for? To support the deployment of 100,000 sensors over 2 years, leverage Amazon S3 for scalable and cost-effective storage of sensor data. Organize the data logically within S3 buckets, and use AWS IoT Core for secure ingestion, connecting and managing the large-scale IoT deployment efficiently. AWS Lambda can be employed for real-time or batch data processing, triggered by new data arriving in S3 or other relevant events. For analytics, utilize Amazon Redshift, a fully managed data warehouse, to query and analyze historical sensor data. Periodically load aggregated or processed data from S3 into Redshift for efficient querying. AWS Glue simplifies the extract, transform, load process, automatically discovering and cataloging metadata for data preparation. Additionally, monitor the entire infrastructure using Amazon CloudWatch to ensure efficient and reliable operation. This architecture provides scalability, durability, and cost-effectiveness for the startup's analytics requirements over the extended data retention period. Suppose you have an application where you have to render images and also do some general computing. Which service will best fit your needs? For an application involving image rendering and general computing tasks, Amazon EC2, Elastic Compute Cloud, is the ideal service. EC2 provides scalable virtual servers, allowing you to select instance types tailored to your specific requirements. If image rendering demands graphics processing, EC2 offers GPU instances for efficient parallel computation. For general computing tasks, EC2 provides instances optimized for compute workloads, ensuring a balanced allocation of resources. The flexibility of EC2 enables you to scale resources based on the varying demands of your application. Whether handling intense image rendering or general computing, EC2 allows for efficient resource allocation. Additionally, features like EC2 auto-scaling and the use of spot instances for cost savings enhance the adaptability and cost-effectiveness of the infrastructure. Overall, Amazon EC2 offers a versatile and scalable solution to accommodate the diverse computational needs of your application. You have decided to change the instance type for instances running in your application tier that are using auto-scaling. In which area would you change the instance type definition? When changing the instance type for instances running in your application tier that are using auto-scaling, you would typically update the instance configuration within the auto-scaling group settings. Specifically, you would modify the launch configuration or launch template associated with the auto-scaling group to specify the new instance type. After updating the launch configuration or launch template, the auto-scaling group uses the new instance type when scaling in or out based on the defined policies. Keep in mind that changes to the launch configuration or launch template take effect for new instances launched by the auto-scaling group. They do not affect existing instances. If you want the existing instances to use the new instance type, you may need to terminate and replace them through the auto-scaling process. You have a content management system running on the Amazon EC2 instance that is approaching 100% CPU utilization. Which option will reduce the load on the Amazon EC2 instance? To reduce the load on an Amazon EC2 instance approaching 100% CPU utilization, consider implementing auto-scaling. Configure auto-scaling to automatically add more EC2 instances to distribute the load, ensuring optimal performance and preventing resource saturation. This dynamic scaling approach allows your application to handle increased demand by horizontally scaling the number of instances based on defined policies, thereby reducing the burden on individual instances. What does the connection draining do? Connection draining is a feature provided by Amazon Elastic Load Balancer (ELB) that ensures a smooth handling of in-flight requests when instances are being taken out of service or replaced. When connection draining is enabled, the load balancer stops sending new requests to instances that are being deregistered or experiencing issues while allowing existing in-flight requests to be completed. This prevents abrupt disruptions in service and provides a graceful transition during scaling operations or instance failures. In summary, connection draining allows the load balancer to gradually stop sending traffic to instances that are being taken out of service, giving those instances time to complete ongoing requests before they are fully removed from the load balancer's rotation. This ensures a seamless user experience and minimizes the impact of changes to the underlying infrastructure. When an instance is unhealthy, it is terminated and replaced with a new one. Which AWS service does that? When an instance is unhealthy and needs to be terminated and replaced with a new one, AWS Auto-Scaling is a service that can automate this process. Auto-scaling monitors the health of instances within an auto-scaling group and takes action based on configured policies. If an instance is deemed unhealthy, for example, due to failed status checks, auto-scaling can terminate the unhealthy instance and launch a replacement to maintain the desired capacity. By defining health check configurations and scaling policies, you can ensure that instances are automatically replaced when they become unhealthy, improving the overall availability and reliability of your applications. What is the lifecycle hook in autoscaling? In AWS autoscaling, a lifecycle hook is a mechanism that allows you to perform custom actions before instances are launched or terminated. These hooks enable you to control the lifecycle of instances during the scaling process. There are two types of lifecycle hooks. 1. Predefined lifecycle hooks and 2. Custom lifecycle hooks. When an instance is in a wait state due to a lifecycle hook, it does not proceed with the launch or termination until you complete the required action. This gives you the opportunity to customize and integrate your own processes into the auto-scaling lifecycle. Typical use cases for lifecycle hooks include performing application setup, configuring instances, or ensuring that an instance is ready to handle traffic before it is put into service or terminated. These hooks provide a way to coordinate with other systems or services as part of the scaling process. A user has set up an auto-scaling group. The group has failed to launch a single instance for more than 24 hours. What will happen to auto-scaling in this condition? If an auto-scaling group fails to launch a single instance for more than 24 hours, auto-scaling will stop attempting to launch new instances for that group. This is part of the default behavior to prevent continuous unsuccessful attempts, which could occur if there are persistent issues preventing instances from launching successfully. After reaching this limit, auto-scaling does not attempt to launch any new instances until the launch configuration or launch template is updated or the desired capacity of the auto-scaling group is modified. Once changes are made, auto-scaling resumes its attempts to launch instances based on the updated configuration. It's important to investigate the root cause of the launch failures, update the launch configuration or template if necessary, and monitor the health of the instances and the overall auto-scaling group to ensure successful scaling in the future. You have an EC2 security group with several running EC2 instances. You change the security group rules to allow inbound traffic on a new port and protocol and launch several new instances in the same security group. When or how the new rules will apply? When you change the security group rules to allow inbound traffic on a new port and protocol, the new rules apply immediately to all instances associated with that security group. This includes both existing instances and any new instances launched in the same security group. Security group rules are stateful, meaning that changes take effect for both new inbound connections and existing connections. The rules are applied dynamically, and there is no need to restart or modify running instances for the changes to take effect. As soon as you update the security group rules, all instances within that security group will be able to receive inbound traffic on the specified port and protocol, whether they are existing instances or new instances launched afterwards. This provides a flexible and immediate way to control network access for your EC2 instances. You would like to create a mirror image of your production environment in another region for disaster recovery purposes. Which AWS resources do not need to be recreated in the second region? When creating a mirror image of your production environment in another region for disaster recovery purposes, the AWS resources that do not need to be recreated in the second region are 1. IAM roles, IAM1 roles. IAM roles can be reused in the second region. This ensures that the same access controls and permissions are maintained, and you don't need to recreate roles from scratch. And 2. Security groups. Security groups can also be reused in the second region. If you've defined specific security group rules for your production environment, you can use the same security groups in the disaster recovery region to maintain consistent network security settings. While IAM roles and security groups can be reused or referenced, keep in mind that certain region-specific resources, such as VPCs, subnets, and certain networking configurations, may need to be recreated in the second region. Additionally, resource dependencies should be considered to ensure a consistent and functional environment in the disaster recovery region. A customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which options should he apply to his application? For capturing all client connection information from a load balancer at regular intervals, the appropriate option is to enable access logs on the load balancer. Enabling access logs on the load balancer allows you to capture detailed information about each request made to the load balancer, including client connection information. Access logs provide details such as the time of the request, the client's IP address, the request path, and more. By configuring access logs, you can collect this information and analyze it at regular intervals. In summary, enabling access logs on the load balancer is the recommended choice for capturing detailed client connection information at regular intervals. Which of the services you would not use to deploy an app? In AWS, there isn't a single service that is universally unsuitable for deploying an application, as the choice of services depends on the specific requirements and architecture of the application. However, if the goal is to deploy a traditional, monolithic application with minimal scalability and flexibility, then services like AWS Lambda, a serverless compute service designed for event-driven applications, might not be the most suitable choice. Additionally, if the application requires manual management of infrastructure and doesn't need the benefits of serverless or fully managed services, using Amazon EC2 instances directly might not be the most efficient option. In such cases, other fully managed services like AWS Elastic Beanstalk or AWS Fargate could be more suitable for streamlined deployment and management. Ultimately, the choice of AWS services for deploying an application depends on factors such as the application architecture, scalability requirements, deployment model preferences, and operational considerations. Each AWS service has its strengths and is designed for specific use cases, so the decision should be based on the unique needs of the application and its intended workload. How does Elastic Beanstalk apply updates? AWS Elastic Beanstalk applies updates to your application environment in a manner that minimizes downtime and ensures a smooth transition. AWS Elastic Beanstalk applies updates using a rolling deployment strategy, gradually updating instances one at a time to minimize downtime. It deploys the new version or configuration changes in batches, conducting health checks before marking instances as updated. If an issue arises, Elastic Beanstalk automatically rolls back to the previous version. Additionally, users have the option for blue-green deployments, where a new environment is created and tested before traffic is shifted. This approach ensures a smooth transition and high availability throughout the update process. You have created a key in the Oregon region to encrypt your data in the North Virginia region for security purposes. You added 2 users to the key and an external AWS account. You wanted to encrypt an object in S3, so when you tried, the key that you just created was not listed. What could be the reason? The most likely reason why the key you created is not listed when attempting to encrypt an object in S3 could be because the key you created should be in the same region. AWS Key Management Service keys are region-specific. When encrypting objects in Amazon S3, the KMS key used for encryption must be in the same region as the S3 bucket. Since you created the key in the Oregon region, it won't be visible when attempting to encrypt an object in an S3 bucket located in the North Virginia region. To resolve this issue, you should create a KMS key in the North Virginia region or choose a key that is already present in that region to encrypt the S3 object. Always ensure that the KMS key and the S3 bucket are in the same AWS region for encryption operations. A company needs to monitor the read and write IOPs metrics for its AWS MySQL RDS instance and send real-time alerts to its operations team. Which AWS services can accomplish this? For monitoring read and write IOPs metrics for an AWS MySQL RDS instance and sending real-time alerts, the suitable AWS services are: 1. Amazon CloudWatch. Amazon CloudWatch is the primary service for monitoring and collecting performance metrics in AWS. It provides metrics for various AWS resources, including RDS instances, and supports the creation of alarms to trigger real-time alerts based on metric thresholds. And 2. Amazon Simple Notification Service, SNS. Amazon SNS can be used in conjunction with Amazon CloudWatch to send real-time alerts. You can configure CloudWatch alarms to publish notifications to an SNS topic, which can then notify the operations team through various channels such as email, SMS, or application endpoints. An organization that is currently using consolidated billing has recently acquired another company that already has several AWS accounts. How could an administrator ensure that all AWS accounts, from both the existing company and the acquired company, are billed to a single account? The correct approach for ensuring that all AWS accounts, from both the existing company and the acquired company, are billed to a single account is to invite the acquired company's AWS account to join the existing company's organization using AWS organizations. By using AWS organizations, you can consolidate billing across multiple AWS accounts. After inviting the acquired company's AWS account to join the existing company's organization, you can set up a payment method in the master payer account to cover the charges for all member accounts within the organization. This allows for centralized billing and management while maintaining separate AWS accounts for each entity. A user has created an application which will be hosted on EC2. The application makes API calls to DynamoDB to fetch certain data. The application running on this instance is using the SDK for making these calls to DynamoDB. Which is the best option concerning the best practice for security in this scenario? The best practice for security in this scenario is that the user should attach an IAM role to the EC2 instance with the necessary permissions for making API calls to DynamoDB. IAM roles are the recommended approach for granting AWS service permissions to your EC2 instances. By attaching an IAM role to the EC2 instance, the application running on that instance can securely make API calls to DynamoDB without embedding long-term security credentials, such as access key and secret key, within the application code. IAM roles can be associated with policies that grant specific permissions, ensuring the principle of least privilege. In this case, the role should have the necessary permissions to allow the EC2 instance to interact with DynamoDB. You have an application running on an EC2 instance which will allow users to download files from a private S3 bucket using a pre-signed URL. Before generating the URL, the application should verify the existence of the file in S3. How should the application use AWS credentials to access the S3 bucket securely? The most secure and recommended approach for an application running on an EC2 instance to access a private S3 bucket, verify the existence of a file, and generate pre-signed URLs is to create an IAM role for EC2 that allows list access to objects in the S3 bucket. Launch the instance with the role, and retrieve the role's credentials from the EC2 instance metadata. IAM roles for EC2 instances are designed to provide temporary security credentials to applications running on EC2 instances. These credentials are obtained automatically and securely from the EC2 instance metadata service. By creating an IAM role for EC2 with the necessary permissions, in this case, list access to the S3 bucket, you ensure that the application on the EC2 instance has the minimum required permissions to perform its tasks. Retrieving credentials from the EC2 instance metadata service eliminates the need to store long-term credentials in the application code or configuration files, enhancing security. That is it for today's episode. We have now covered more than 100 questions and answers in this series. Thank you for joining us in this deep dive into AWS interview preparation in episode 4 of our series. We've covered an extensive range of questions that will undoubtedly help you build a strong foundation for your AWS interviews. Remember, mastering AWS is not just about memorizing answers but understanding the concepts behind them. If you found this video valuable, don't forget to hit the like button, share it with your network, and subscribe to our channel for more insightful content. Stay tuned for upcoming episodes where we'll continue to unravel more challenging questions and scenarios that you might encounter in your AWS interviews. If you have specific topics or questions you'd like us to cover, feel free to drop them in the comments section below. Keep honing your skills and best of luck with your AWS interviews. Until next time, stay curious and keep on thinking.